Hello everyone, welcome to the another lecture of periodic table class 9. Myself Suman Singh. So in the last class we have discussed about the Darwin's triad, right? So in this class we will discuss about the Newland Law of Octaves. So Newland, this is the name of a scientist whose full name was John Newland. Okay, and what he did, he has arranged the element in order of their increasing atomic mass. Okay, and he found out that the eighth one, right? Suppose we are writing like this. I will go through in detail. 1, 2, 3, 4, 5, 6, 7. Right? Up to 7, and the eighth one will resemble as the property, same property as 1. Ninth one will same as a 2. 10th one will same as a 3. 11th one will be same as a 4. 12th one will be same as a 5. To 13 one will be same as a 6. 14 one will be same as a 7, and again 15 one will be same as a 1. So in this way he arranged the element in order of their increasing atomic mass, and he told that the when the element are arranged in increasing in order of their increasing atomic mass, the properties of every eighth element starting from any element are repetition of the properties of the starting element. Means the properties of this eighth element will be same as the properties of this one element and the number one element, and 2 will be same as 9, 3 will be same as 10. Okay, so I hope you have got the basic idea. Right, now we will see what is written in your book. So John Newland was the name of the scientist. He was a he was a very scientist of a music level. So what he did, he arranged the element in order of their ascending order of atomic mass. Okay, in order of ascending order of atomic mass. Okay, and what he found that in order of their ascending order of the atomic mass, and he found that the every eight element, what I have already told you, every eight element had a property similar to the properties of the first one, similar to the property of the first one. Okay, first one, just as the eighth note of musical octave. Okay, similar to the musical octave in the same as its first note. Okay, so what he found that every eight element had a property similar to the properties of the first element just at the eighth note of musical octave. In a musical octave is the same as the first note, right? Now based on his observation, what he did, Newland suggested a classification which is known as Newland law of octave, right? So what was its classification? How we can define its classification? He defined that when he defined like this, as you can see from here, this table, from this table you will understand. What he found that when the element are arranged in increasing order of their atomic mass, as you can see, for hydrogen, after that lithium, after that beryllium, boron, carbon, nitrogen and oxygen, like this, when the element are arranged in order of their increasing atomic mass, right, the properties of every eighth element which is what, fluorine, right? The eighth element, the property fluorine, and for this it is sodium, for this it is magnesium, for this it is aluminum, right? The properties of every eight element starting from any element are repetition of the properties of the starting element. Means what, if the one which is in the eighth position will be the way will have a property same as the first one, like this. If we are counting from here, 1 2 3 4 5 6 7 and 8, 8, this one is 8, so this will be same as this. Again, if we are starting from here, it will be 8, so this will be same as this. If we are starting from here, this will be 8 as the same as it is. If we are starting from here, this will be 8, right? So this was his classification. He told that when the element are arranged in order of their increasing atomic mass, the properties of the every eight element starting from any element are the repetition of the properties of the starting element, right? Now what we can say, this Newland divided the element into horizontal rows, as you can see, horizontal rows, right? And horizontal rows, and 7 vertical and horizontal rows of 7 element, each so above in as a is shown above, as you can see here. And inner gases were not known at that time, because whatever the noble gases which we are using in right till right now, right, helium, neon, argon, krypton, xenon, radon, at that time it was not known at that time, right? So helium, neon, argon, xenon, radon was not there at that time, right? Now next one is, what is the merit, or we can say that what is the uses of this Newland classification? What was the revolution? What was the importance of this Newland law of octave? So the merit was, this system worked quite well for the lighter elements. Okay, when we talk about this system worked quite well for the lighter element. For example, for lithium, sodium, potassium, where because this lithium, sodium, and potassium, since they have a similar chemical properties, they were brought together, right? So this system somehow worked quite well for the lighter element. Now, next is, it relates the property of the element to their atomic masses. So what he did, he related the properties of the element to their atomic masses, right? Now next one, for the first time it shows that there is a distinct periodicity in the properties of the element. He was the first scientist to show that there is a distinct periodicity in the properties of the element. Means what, there is a similarities between the properties of the element. Okay, now for his work, he has received the Royal Society presented a Davy Medal to the to a Newland in 1887 for his work on the classification of this element. Right. Now next is reason for discarding the law of octave. What was the reason why this Newland law of classification has failed? Because we are using here now modern periodic table, right? So why it has failed, we will see this. The first reason is, this element did not work with the higher element, right? Because it was only limited to 20 elements, just up to calcium. It did not work with heavier element, those lying beyond calcium, as I have already told you, right? And as the more and more elements were discovered, they could not be fitted into the Newland's octave, because when more and more elements were discovered, the Newland law of octave has failed. Now next is, Newland adjusted two elements, which is cobalt and nickel, in the same slot, and these were placed in the same column as fluorine and chlorine, and fluorine, chlorine, and bromine. Just try to understand this. What did Newland do? Newland has put this cobalt, CO, and this nickel in the group where fluorine and chlorine is there, as you can see in this table, right? You can see here cobalt and nickel were placed with this fluorine and hydrogen and chlorine and bromine, right? So what did he do? Newland adjusted the two elements, this is cobalt and nickel, in the same slot as as this was placed in the same column as fluorine, chlorine, and bromine, which have a very different properties at this element, because he has placed here only. But what did he tell? He told that this all have the same property, but later on we found out that this cobalt and nickel has a very different property with this fluorine, chlorine, and bromine, right? Now next was the third drawback was, iron, which resemble cobalt and nickel in their property, has been placed far away from this element. This one, iron, this resemble the property of this cobalt and nickel, but you can see it is placed very far away from here, right? So this was some of the drawback of Newland law of octave, right? So I hope you have understood this, what is Newland law of octave, right? So today we will not discuss much. Keep up to this. In the next class we will discuss about the Mendeleev periodic table, right? So till that, thank you.